My goodness, this thing is really big. How do we get it back to normal? Gosh, it seems really big still. All right, well, maybe that's just going to have to be. All right, guys, we're on chapter 13, which is probability and measurement. You're definitely going to have a calculator available. Not quite for sure how quickly we'll go through these. This one might take 2 days, not 100% sure, but here we go. So we're talking about sample space, and this is something that I taught like in 7th grade. So I don't know if you guys missed it because you guys were always in like pre-algebra or something. So it might be something like that. This is a little bright as well. Let's see if we tone that down. Here we go. Is that looking better? I think that's looking better. Anyway, so really, sample space is the total number of outcomes. So here is some vocabulary. So they have like experimental probability. That's an actual experiment. And it'll say, an outcome is a single performance or trial. An event is one or more outcomes of that experiment. All right, so sample space lists all the possible outcomes for an event. A 2-stage experiment is an experiment that has at least 2 outcomes, like tossing 2 coins instead of 1. And then there's different ways that you can show it. Here's a nice organized list based on tossing of 2 coins. So heads, 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 tails, tails, heads, tails, tails. You can list it in an organized list, a table, or what's called a tree diagram. A multi-stage is where there are multiple choices. And this is one of my favorite, especially when my daughter was in middle school and she always said, I don't have anything to wear. And I would always use this one. So you can have hamburger or hot dog with mustard, ketchup, or relish on it. So these are all your different choices. And you can list them in a tree diagram, a table, organized list, and we'll get into that a little bit more in another part of this. So let's say I have 1 token, 1 red token, and 1 black token, and they are placed in a bag. A token is drawn and the color is recorded. Then it is returned, because sometimes they are not returned, so that changes things, to the bag, and a second draw is made. So represent the sample space for this experiment by making an organized list, a table, and a tree diagram. So you just have to start, let's just pretend you're doing it. So you're choosing a token. Well, let's pretend it's red. Okay. I take that token and I put it back in, and then what are my choices of choosing another? So if I choose something else, I might choose another red one. Well, if I chose the red one, my next one might be a black one. Same thing with black. If I chose black, I might choose a red. Or if I chose black and then put it back in, I'd get another black. So my outcomes here would either you're getting a red or a black. And this is like what those Punnett squares, like for heredity. So if your outcome was red, I would go red, red. So I'm reading red, red. This one's black, red. This one's red, black. This one is black, black. I do like these, but sometimes they're hard to do. The tree diagram is even, I want to say, worse. So here's my possible outcomes. So I could either have a red or a black. If I chose red, I could get red again or black. If I chose black, I could get red or black. So my outcomes are really these things. Toot, toot, Doot, doot. So I have, again, 4 different possibilities. 4 different possibilities. 4 different possibilities. And then from this, you can say, well, what's the probability of getting red, red? Well, it's 1/4, 1 out of these 4. So you could say 25%. What is the probability of getting any of these? Is 25%. Because of the 4 outcomes. 1 of the 4 outcomes. Okay. Next. I think this is just kind of showing what we just did. But the question is, 1 yellow token and 1 blue token are placed in a bag. A token is drawn and the color is recorded. It is then returned to the bag, so it is returned, and a second draw is made. Which one of these is correctly displayed? So yellow, 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 blue, blue, yellow, that's not. So this should be blue, yellow, right? So this is a no-go. Bad. Yellow, yellow, blue, yellow, yellow, blue. This should be blue, blue, right? It should be blue, blue. All right. So far, no good. This one, we have yellow, blue. We could either get a yellow or a blue. If we had blue, we could either get yellow or blue, which makes this yellow, 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 blue, blue, yellow, blue, blue. Yay! This is obviously is missing 1, so he's out. So which one are they missing? Blue, yellow? All right. So here we have a chef's salad at a local restaurant. It comes in a choice of French, ranch, or blue cheese dressings. And your toppings are cheese, turkey, and eggs. Draw a tree diagram to represent that sample space. So you have your chef salad. You can either have French, ranch, or blue cheese. If you chose French, you can have cheese, no cheese, cheese, no cheese, cheese, no cheese. You can have, if you chose this, do you see where we're going here? Turkey, no turkey. 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 Wow, our outcomes. Think about how many outcomes, how many possible outcomes. Okay, so the next thing is eggs, no eggs, right? Eggs, no egg. Egg, 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 no egg. Oh my gosh. Egg, no egg. Egg, no egg. Egg. Oh, I'm running out of room. How many more of these do I have? What is that? 2, 4, 6. So there's 6 more of these. Egg, no eggs. Okay, so what are we counting? Oh, we're just drawing the tree diagram. So you can actually see how many outcomes there are. There were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24 outcomes? Wow. All right, so that's how you make a tree diagram. Next, all right, baseball game in the bleachers at a major league game. You purchase a hot dog. You can purchase a hot dog, a brat, or tofu dog. This comes in the optional choices of ketchup, mustard, onions, and relish. How many stages? So that was how many different things do we have? How many options? You can purchase a hot dog. That's one option. And then these choices. So that's like hot dog, ketchup, mustard, onion, and relish. So it's 1, 2, 3, 4, 5. So there's 5 options or stages. All right. This fundamental counting principle is that you're just multiplying. So you are multiplying the outcomes. And this looks like a mess. So I'm going to go ahead and show you an example. So here's our example. We have cars. New cars are available with a wide selection of options. One option is to choose from each category shown. How many different cars could a consumer create in the chosen make and model? So we have our car options, and all we're doing, so the fundamental counting principle is you're multiplying your options. I shouldn't say outcomes. Maybe I should say options. Let's get rid of that. Okay. All right, so we're going to say 11 times 7 times 5 times 3 times 6 times 4 times 3. We take that into our calculator. Believe it or not, you have 83,160 options. And this is the one I always used with my daughter when she had no clothes, because you could say, oh, how many jeans, how many shirts, how many whatever, and you multiply them all together, and you have that many options. Bicycles. New bicycles are available with all kinds of options. We're doing the same thing. So we're just multiplying our options. Multiplying those options. So 9 times 3 times 3 times 4 times 2 times 3 times 2. Multiply that. You get 3,888 options for your bike. That's pretty good. It's pretty amazing, actually. All right. That is it.